The line left of the critical point on the dome is the saturated liquid line. That means the vapor fraction anywhere on the line is 0. However, the line to the right in the dome is the saturated vapor line. That means the vapor fraction on that line is 1. Any point between those two lines then has a vapor fraction value between 0 and 1. The relation between position in the dome and vapor fraction is linear. That is, a point halfway between the saturated vapor line and the saturated liquid line has a vapor fraction of 0.5. A point that is 3 times farther from the liquid line than the vapor line has a vapor fraction of 0.75. This kind of calculation follows the lever rule. We can draw a line between all points that have the same vapor fraction to give a constant x line. Note that the saturated vapor line is a constant x line with x is equal to 1, and a saturated liquid line is a constant x line with x is equal to 0. Lever rule. At point A, x is equal to vapor fraction, 1 minus x is equal to liquid fraction. Point A represents a mixture of saturated liquid and vapor at pressure PA. The enthalpy at A is a weighted average of the enthalpies of the saturated phases. The lever rule can also be used for other properties besides enthalpy, like volume. Reading pressure. Since this is a Ln pressure enthalpy graph, the natural logarithm of pressure is marked on the y-axis. Then, any horizontal line is an isobaric or equal pressure line. Reading enthalpy. Since this is a Ln pressure enthalpy graph, the enthalpy is marked on the x-axis. Then, a vertical line is a line of constant enthalpy. Reading temperature. Temperature is slightly harder to read than other properties. An isotherm or equal temperature line has a downward slope until it hits the liquid vapor dome. Once the line hits the liquid vapor dome, the isotherm has no slope and is horizontal. Once the isotherm leaves the liquid vapor dome, it has a negative slope again.